In this video, I'm going to explain IP addresses in details. So, for instance, if I have 192.168.29 and 24 IP address, so we call this IPv4 and it has 32-bit range. So, how do you know this? It got 32-bit range. So we call it has 4 octets. Oct means 8, so it got 4 8s, so this is gonna be 32. Then how do you know this one get a this has actually 8 bits, so that is 1 octet. Then how do you know this? How do you calculate this? How did they get this? Then if you do, for that, 2 power 0, 1, 2, 3, 4, 5 and 6, and anything power 0 is 1, 2, 4, 8, 16, 32, 64, and add 2 power 7, that is 128. So if you count them, these are going to be 8 numbers: 1, 2, 3, 4, 5, 6, 7, 8. Okay, then if I had to get to 192, then how you going to do? You need to select numbers from these range. Okay, and then wherever you need a number, just put 1. So I need 128, I'm going to put 1. Then if I had 64, then that's going to be 192, right? 72, yeah, 192. So the remaining numbers just add 0 because you don't need any of these. So that is going to be 11 00 00 00 00. So this is 1 octet. And then 168, how you gonna get? And let's do the same thing again. I need 128, and if I had 64, this is gonna be 192, so I don't need this number. If I had 32, that is gonna be 160, and I need 8 more. So here I need 0 and I need 8, so I'm gonna add 1 0 0 0. So that is gonna be, oh, I forgot to add 1 here because I need 32 as well. 101 01 and 000. This is 168, and do the same for remaining numbers. So I'm not going to do that because that's enough for. So that is how you get 32 bits. So that's the reason we usually, when we get subnet, we need to subtract the value from 32. So for instance, if I have 192.168.0.0/24, then how many IPs you gonna get? Then what you need to do, just do 32 minus 24, that's gonna be 8. Then whichever the value you're gonna get here, you need to do 2 power, that means 2 power 8. So that is going to be 256. So if somebody asks you how many IPs you're gonna get, just do just subtract this value from 32. Then once you get some value, just do 2 power in that value, and then you're gonna get this many IPs. Then let's do let's take another example. So excuse me. So if you do 192.168.0.0/25, if they ask you how many IPs you're gonna get, just do 32 minus 25, that's going to be 7. So then what you're gonna do, 2 power 7, so that is going to be 128, I believe. And these many IPs you're gonna get. And in reality, how many IPs you're gonna get actually? So if I take this to cloud, just remember this, you're gonna lose 5 IPs in the cloud. So 5 IPs minus, so that means if I take slash 24 thing, that's a 256 minus 5 IPs. So you're gonna see just 251 available IPs. Okay, I'm talking about available IPs. But if you take your network, for instance your home network, how many IPs you're going to lose? 2 IPs. Okay, 2 IPs in home network. Let me explain. So what are these 5 IPs? So if I take slash 24, we're gonna get 256 IPs. Then for instance, if I go for this network range 0.0 slash 24, I'm gonna get 256 IPs, right? As I said, 5 IPs you're gonna lose. That those 5 are 192.168.0.0, 192.168.0.1, 192.168.0.2, 192.168.0.3, and then the last IP. First 4 IPs and the last one. So 192.168.0.255. So whenever you launch a machine such as EC2 on AWS, you're not going to get these 5 IP addresses. Other than these, you can get the range from 4 to 254. These IPs you can get. Okay, even you can check that. What you can do actually, just go to create a subnet with this range, and whenever you creating a machine, EC2 machine, try to assign these private IPs. In later lectures, I'm going to show you that as well when we do practicals on AWS. I'll show this how we are going to lose these IPs. Just for time being, just remember you're going to lose 5 IPs in the cloud, and in your home or other network, maybe non-cloud, you're going to lose 2 IPs, and those 2 IPs are in local network, not cloud. For instance, if I take the same example, you're going to lose first IP and the last IP. So that one is 192.168.0.0, the first one, and 192.168.0.255 is the last one. So we call the first one as a network address, or network ID, or host ID, because this is the uh, network address for now. Okay, that is a network address, and the last one is, so this is network address, and this one is broadcast ID, we call it. This one is broadcast ID. So that's how these 5 IPs in the cloud, we call them as reserved IPs. If you simply Google it, you're gonna get that. This is a broadcast network address, and this one is broadcast, and the remaining 3 are one for DNS and one for future reserved and one for something else. I can't remember, but just make sure remember these. You lose 5 IPs in the cloud, and those are reserved IPs, and first 4 and the last one. Excuse me. Okay, and if I do 2 power 32 now, that's you're gonna get 429, 496, and 72996. These many IPs you can get. Even still, if you, in my home I got 8 devices. Many people, they do have multiple devices. So if it is globally assigned to multiple devices, these IPs are not going to enough. That's why they got the concept as private IP addresses. So for instance, in my Wi-Fi, I have mobile and one laptop and one iPad. So these iPad, if I go to settings, Wi-Fi, I can see my IP address here, 192.168.29.45. Let me write it down. Or 192.168.29 and 45. If I check it on mobile, and my mobile's IP is 192.168.29.182, and my laptop's IP is 29 and 162. But this is my private IP, okay? It is accessible only inside my network, okay, inside my home only. If someone tries to reach this IP, they're not going to reach it, because this is not my public IP, okay? If I visit any website or any application, how do they know my IP address? So that is, if you come over here, if you look for what is my IP. So I got a couple of IPs, IPv4 and this one, and IPv6 the second one. So that ends with 49, 43, 231, 48, okay, 148. Now if I go to my mobile, 48. That means if I have laptop, if I have any other devices on my Wi-Fi, they're gonna get the same public IP. For 20 or 30 devices, maybe they're gonna get different private IP addresses as shown, but they're gonna have the same public IP. So that means even if I have 20 devices at my home, I just need one public IP, right? That's how I save many IPs. But if it is the same network, if I use mobile network, I'm gonna get a different IP address. But in my case, I got Wi-Fi, so I just need one public IP address, and this IP address. Who gives you this IP address? ISP, that is Internet Service Provider. In my case, I got Geo. If you got Airtel, Airtel is gonna be your ISP. And let's come to this Class A, Class B, and Class C. What are these classes actually? So, of course, we got Class D and E, but let's stick to Class ABC for now. Class A, Class B, Class C. Just I have bad handwriting. Sorry, mate. Just in Class A, it's gonna be 10, 0, 0, 0, 2, and you're gonna get 172.0.0.0. So you're gonna get in this IP range. If I do the Class B is 172.16.0.0. Of course, we got CIDRs, but I'm not going to write it here. And then 192, 168.0.0. And the Class C is 192, 168.0. Sorry, this is 1.0.2. Uh, that is 192, 255, 255, and 255. You can Google it, you're gonna get all of these numbers though. Then what does it mean actually? So as we check our IP address 49, 43, this one, so that just compare it in which range it's gonna fit. So it's gonna fit in this range, because 10 to 172, so it starts from 49. So if I go to Google, let me do nslookupgoogle.com. Come on. Okay, ns lookup. Okay, they have a IP range of 142, I can see, 250, 194, and 14. So still they have an IP range of this one, Class A. So the Class A for large companies and ISPs, Internet Service Providers, and Class B for small to medium range companies, and this one for home networks. And this is we usually use Class C when we create subnets. So let's do that. Then why do you need subnets actually? So 192.168.0.1/24, for instance 0.0. You may have 172.17.0.0/24, and this is one subnet. This is another subnet in different range though. So basically, why do you need the subnets actually? So imagine you got 192.168.1.0 as another subnet. So you just imagine you got some web server, so you need to put them in public internet. So you need a public subnet for that. Let's say 192.168.0.0/24 is public subnet, and you got 192.168.1.0/24 as private subnet. So in private subnets, you want to divide this network. You got a big network, then you want to divide it. In private subnet, you want to put some DB for security. You don't want to expose them to public internet, and you got web application that you want to put that in public subnets. So if you want to get these, you need to divide them. Of course, when you excuse me, when we discuss these things on AWS with the help of VPC and subnets, we can get a practical idea on that. But for now, just try to remember these things, and then that's how you're going to divide your network for various use cases. Then, when it comes to subnet mask, how if someone asks you 192.168.0.0/24, what is the subnet mask for this one? Of course, I can say that 255, 255, 255, and 0. I can say that. Then how do I know? How do I know this? So if we do 192.168.0.0/24, that means 32 minus 24, that is going to be 8. So this one is 8, this one is 8, 8, and this number is 8. So I got 1 8. So what does it mean actually? So I can get 192.168.0.0 to 192.168, for instance 0.1, 192.168.0.2 till 255, right? 192.168.0.255. These 255 plus 1 plus 0, that's going to be 256 IPs altogether. So that means I just need to change only this part, this number only. I don't need to change these numbers. So that's why I call it 255, 255, 255, and 0. This is the subnet mask. Subnet mask for /24. Okay, let's take another example. I got another network with 192.168.0.0/23. Now, what is the subnet mask for this IP? Then if I do 32 minus 23, that's gonna be 9, right? If I do 2 power 9, that's gonna be 512 IPs. And then if I come over here, 192.168.0.0 is 1, 192.168.0.0, sorry, 1, and here 192.168 till 0.255. So if I add all this, I'm gonna get 256 IPs. Then how can I get the remaining 256 IPs from out of 512? I got only 256. That's where you're gonna increase this number. So 192.168, 1.0, 1.2, this is gonna be same, and the last one is 192.168, 1.255. So here you got 256 IPs more. So if I combine these is gonna be 512 IPs. Then what is the mask for now. Then what are you gonna do? You don't need to change this number. That's why you got 255. You don't need to change this one, 255, and you got this one changed. You changed this number earlier for this subnet slash 24. You didn't change this number, but now you changed it. So that means just how many times you change? Just once. So just do 254. So 255 minus 1. So that's gonna be 254.0. So this is your subnet mask. Let's take another example. Of course, this one clears your doubt. So if you get 192.168.0.0 slash 22, then how many IPs you gonna get? Of course, we can do this. 32 minus 22, that's gonna be 10. That is 2 power 10. That means I think you're gonna get 1024 IPs. Let me make sure. That is 2 power 10. Yes, so you're gonna get 1024 IPs. So how you gonna get 1024 IPs? So 192.168.0.1 0.0 and then 192.168.0 dot, for instance 255. So you got 256 here, and then 192.168 1.0 192 168 1.255. You got 256 here. Just 512. You need 1024. Then take 192 168 1.0, sorry 2.0, and then 192 168 2.255. You got 256 more here, and then 192 168 3.0, and then 192 168 3.255. So 256 here. So altogether, if you add for all these, so that's gonna be 1024. So then what is the subnet mask? So this one you don't need to come on. So this number 192 you don't need to change. So 255 you don't need to change, 168 as well, 255, and then here you changed 1 2 3. So 255 minus 3, that is gonna be 252. So that's 252, and you need to change this number all the time, so just put 0. So this is how you're gonna get subnet mask. I hope this one clears all your doubt. Just practice this multiple times to get an idea, and this is gonna be enough for this video. Thank you so much for watching.